Okay, we have here today on the board this sum 1 minus 1/3 plus 1/5 minus 1/7 plus 1/9, on and on to infinity. And you may recognize this, you may already know the value of this thing here. This here is actually going to converge to the value of pi over 4. And I think the most common way to do it is just using the power series for arctan. If you use this formula here, you'll notice on everything here we have odd numbers in the denominator. So this is the 2n plus 1. That's always going to go with the odd numbers. Alternating sign is created by this. And then to get rid of this x, all we do is we just plug in a 1 right here. So for the value of arctan of 1, this here is just going to simplify down to just minus 1 to the n over 2n plus 1, just because 1 to the n is always going to be just a 1. But arctan at 1, that just has a well-known value of pi over 4, and that's a quick way to do it. But what I want to do is get rid of this and find a different way to get at it using the Digamma function. And what I'm going to do is I'm going to write this series in a completely different way. We can write this as the sum from n equals 0 to infinity of 1 over 4n plus 1 minus 1 over 4n plus 3. If you plug in n values starting at 0, what you'll notice is the first value is going to be 1 minus a third. You plug in 1, you get a fifth minus a seventh, on and on. So this is the same thing as our sum here. But then next, I don't really like the 4 on the end, so let's factor this out as a 1/4 in front of our sum. And now with what we have here, let's look at our series expansion for the Digamma function and see how we can use it on this expression here. Now, if you need more information on the Digamma function, I've done a bunch of videos, so I'll provide a link to the playlist and you can look at some of the details on this. Now, looking at our series expansion for the Digamma function, you'll notice we've got this is the Euler-Mascheroni constant, something like 0.577. That's not going to bother us because we can just bring that on the other side of the equation. What I'm focused on is trying to get it where this part is going to match our sum, so we have a way to kind of transform this. Well, this would be fine if we call this our z value, the input here on the Digamma function, but the problem is this needs to be n plus 1, and over here we've got a 1/4. So the way I'm going to deal with this is actually just creating a second copy of the Digamma function, just using a different input. We're going to call the input s now, and just all the same stuff. And now that we have a copy of this in S, let's just subtract these two equations. When we do that, the Euler-Mascheroni constants are going to cancel out, which is nice. We don't need that. So now we're going to have this expression for Digamma of Z minus Digamma of S. Then when we put these two sums together, notice the 1 over n plus 1s, because we're subtracting, these are going to cancel out. And then so what we're left with now is going to be this sum, this minus times minus is a plus, so it's going to become 1 over n plus s minus 1 over n plus z. But now this formula at the bottom, this is going to be perfect for what we have. So kind of matching up, like this 1/4 is going to be our s value here. And this 3/4 value, that's going to be the z value. So putting this to use, we still have our 1/4 in front, and then this is all going to transform. We can write it this way as Digamma of the z value, which is 3 over 4 minus Digamma of 1 over 4. And so this is kind of a solution, but it's definitely not pi over 4. It doesn't look like pi over 4 yet. Now, one thing we can notice here is if you add these two inputs together, they add up to 1. Both values are between 0 and 1. So what that tells me is we can use the reflection formula on this. Using this formula, the input, so we have our z here, we can transform this expression into something in terms of cotangent. So what's going to happen here, we have our 1/4 in front. All this is going to become pi times cotangent pi of z, which is 1/4. So I can write this as cotangent pi over 4. But now cotangent pi over 4 is the same as tangent pi over 4. This value is just 1, so that's going away. Multiply pi times 1/4. For my final solution to this, we just get pi over 4. Okay, so there you go. Definitely more work than if you did it just using arctan, but still, I always find it interesting. I love the Digamma function, so I'll do a million problems this way, and I'll do everything I can with the Digamma function. Okay, that's it for today. Thanks everyone for watching. Have a good day.